Okay, this is 7.3. This is page 4, and this is partial fraction decomposition. And the idea is, let's say you had you have two rational expressions like we have here, and you have the sum or difference. In this case, we have the difference of two rational functions. And we said that we asked you to solve this. So what would you do? You would come in here and you would get rid of the denominator. Basically, you would want to. In fact, I don't have to write out there. You say, okay, if I'm going to simplify this, then I need to get rid of the denominator. So I'm going to multiply the whole thing by the what is the lowest common denominator, right? So we multiply. We would get, sorry, got distracted there. So we would go x plus 2 times x plus 4, right? We multiply that by the first term. The x plus 2's cancel out. It leaves us with 3 times x plus 4. And then we do the second thing here, and then we multiply that whole thing by 2 over x plus 5. And again, this is basically, we're just getting rid of, leaves me with 2x plus 2, right? Because they canceled out the denominators there. All right, then we would just simplify this. So we would get 3x plus 12 minus 2x minus 4. Combine that, 3x minus 2x is x. 12 minus 4 is 8. And so we would have x plus 8. So that's when we have the sum, or in this case, a difference of two rational expressions. And so what partial fraction decomposition does is basically work the problem backwards. So it gets us going from an equation and it turns it into this. And so the purpose is to write a rational expression as a sum of two or more rational expressions. And apparently I haven't looked at calculus in a long time, haven't taught calculus or taken calculus, but this is going to be useful in calculus. All right. So how does this work? Well, step one, okay, is we want to factor the the denominator completely. So we come over here and we have, again, we have a rational expression, okay, and we're going to rewrite this rational expression as the sum of two or more rational expressions. So we're going to basically break this up. So we want to factor the denominator. That'd be x. This is where you're factoring. Those of you who struggle with factoring, boy, this is going to be a long year because all we do is factor. Okay, so that's easy factoring to do. Now we're going to set up we're going to set up a fraction for each one of our factors, and we're going to have a be the numerator, a and b be the numerator, however many equations we have. In this case, it's just going to be 2. So we have a over x plus 4, okay, plus b over x plus 2. And that's going to equal x plus 8 over x plus 4, x plus 2. Okay, so we need to find these values, a and b, and what they're going to be is a is going to be some number times x plus 2, and b is going to be some number times x plus 4, because you'll see this in a minute, sort of the kind of cross multiplication, if you want us to say. So we need to find out what are those values, or what's going to go up there, because this is our goal here, is to take this equation here, this rational expression, and to rewrite it as a sum of two rational expressions, which is what we have here. All right, so the next step is just to multiply everything we have here by x plus 4 and x plus 2. All right. By doing that, over here under the a, we're left with a times x plus 2 because the x plus 4 here and this x plus 4 canceled out. And then we have it plus b times x plus 4, and that's because this x plus 2 and this x plus 2 canceled out. And then equals x plus 8, and we have that because all of this and all of that canceled out. All right, so now we have the equation down here to a times x plus 2 plus b times x plus 4 equals x plus 8. We need to find values. We need to find what a and b are. So in order to solve for b, I need to multiply a by 0. So the first thing I'm going to do is I'm going to say, okay, what value would make a 0? Well, if x equals -2, then I would have a times -2 plus 2 plus b -2 plus 4 equals -2 plus 8. Got it? Now, 2 plus 2 is 0. 0 times a gets rid of that, so that's gone. -2 plus 4, that gives me 2b. And then -2 plus 8 gives me 4. So I divide both sides by 2, and b equals 2. I'm sorry. -2 plus 8 is 6. So b is 3. All right, so now I found b. All right, now I need to find a. So now I'm going to come back up here. I'm going to say, okay, well, what if x equals -4, because that's what's going to make this 0. So again, we'll do some blue. I go a -4 plus 2 plus b -4 plus 4 equals -4 plus 8. Okay, -4 plus 2, that's -2a. -4 plus 4 is 0. 0 times b is 0, so that's done. And -4 plus 8 is 4. So a equals -2. So I now have my values for a and b. I come back up to my original equation here that I'm trying to find, and I put those values in. So my final answer here, a is -2, so I go -2 over x plus 4. Let me just highlight what I'm doing. I'm bringing this down here. And then I go plus 3 over x plus 2. And that's my answer. And so, again, what it means is I have this sum of two rational expressions right here, and that equals all the way up to here. Okay, that's if I were to break it up, if I were to decompose it, that's what it would look like. Or actually, if I were to actually add these together, that's what it would look like. All right. There's two sample problems here, 2 or 3, I don't know. Let's take 3 of them. So let's kind of zip through these a bit. All pretty straightforward. Just if you follow the same steps each time, can't go wrong. So step 1, x plus 7, and I'm going to factor 3, 2, -3 plus 2. Okay. So that is going to equal a over x minus 3 plus b over x plus 2. You'll find that it kind of doesn't matter which way these work out. It'll always still work out. So it doesn't matter really if this was x minus 3 and this is x plus 2. If those were flipped, it would still ultimately work out. Okay, next step is I'm multiplying both sides by x minus 3 times x plus 2. Okay, so this gives me my x plus 7 equals a times x plus 2 plus b x minus 3. Okay, so again, now this is where I'm going to pick different values for x. And again, I'm going to pick a value for x so that this becomes 0, so that I can cancel out the a. And then I'm going to pick a value for x so that this becomes 0, so I can solve for a. So first I'll go and solve for b. So I'll say if x equals -2, That's going to be negative 2 plus 7 equals a negative 2 plus 2. That's 0, right? So that gets rid of that. Plus b negative 2 minus 3. So I have 5 equals negative 5b. Therefore, b equals negative 1. Okay, now I'm going to come in and pick a value. And now what if x equals 3? Okay, now I have 3 plus 7 equals a, 3 plus 2 plus b, 3 minus 3. 3 minus 3 equals 0. 0 times b, that cancels out. This leaves me with 10. This leaves me with 5a. Therefore, a equals 2. And now I have my b and my a. So I come back up here to my equation here, and I plug those values in. So this would be 2 over x minus 3 minus, since it's a negative 1, minus 1 over x plus 2. And that's my solution for number 1. Okay, moving on. I got to erase this. Let's look at number 2 here. I think this one brings in a fraction, so see something different on it. X minus 2 over x plus 3, x plus 1 equals a over x plus 3 plus b over x plus 1. Okay. Again, multiply everything by x plus 3 times x plus 1. Okay, that helps cancel that out, cancels that out, cancels that out. That leaves me with x minus 2 equals a times x plus 1 plus b x plus 3. Okay, pick our values. I'll say x equals negative 1. Negative 1 minus 2. I'm just going to skip this step. We know that's going to cancel out the a. So it's going to leave me with b negative 1 plus 3. So I have negative 3 over 2b. So b equals negative 3 halves. All right, so yeah, we have a fraction there, but that's all right. Now I'm going to come in, I'm going to solve for a. X equals negative 3. So I have negative 3 minus 2 equals a, negative 3 plus 1. And we know that the negative 3 plus 3 is 0, so the b is canceled out. This leaves me with negative 5 equals negative 2a. Therefore, a equals 5 halves. Oh, great. We have fractions all over the place. Not a problem. We are going to go back to this equation here, right? I'm going to write it out with our new our a and our b. Now, pay attention because I want to be good about this. So a is 5 halves over x plus 3 plus negative 3 halves over x plus 1. We are not going to leave that as our answer, okay? That's amateur stuff. We don't have a fraction on top of a fraction like that, okay? We're going to put a little effort into this. We're going to rewrite this. So we would rewrite this as 5 over 2x plus 3, right? Here we have negative 3 2x plus 1, okay? And we'll take it all the way and say this is 5 over 2x plus 6 minus 3 over 2x plus 2. Okay, and that would be our answer, okay? Not this, no, This would be our answer. Okay, last one. Cleaning up my space here a little bit. Okay, again, same principles here. I don't think anything crazy happens with this problem. It's pretty straightforward. Except the factoring is harder. Some of you, if there's a coefficient in front of that x squared, it really messes you up. So this is going to be, let's see, it's got to be 1 times 1, right? Since that's a 1. And that's 2x squared, so that's got to be 2x and x. So now I just make sure I have all of my signs correct. So this is going to be plus, and this is going to be minus. Okay? Really make sure you understand how to do your factoring. Okay. This equals a over 2x plus 1 plus b over x plus 1. Again, multiply everything by 2x minus 1, x plus 1. Oops. 5 minus x equals a x plus 1 plus b 2x minus 1. Okay, now we have to find our values. We'll solve for b first. We'll say if x equals -1, so 5 minus -1 equals a -1 plus 1 plus b 2 -1 minus 1. Clean all this up. 6. Let's see. That's -2. It's -3b. So b equals -2. Okay. Now we want to find a. So if x equals, now in this case it's a little bit harder because it's like, okay, we have to see 2x plus 1 equals 0, 2x equals -1, x equals -1/2. Okay, so x needs to equal -1/2. Come in here, we go 5 minus, oh wait, is it -1/2? I thought it was 1/2. Is it 1/2? Oh yeah, because it's that's, I was going to write it down correctly. I knew that was wrong. This is 2x minus 1, so this is 2x1. Okay, clean that up. It's just 1/2. So x equals 1/2. So 5 minus 1/2 equals a 1/2 plus 1 plus b 2 times 1/2 minus 1. Okay, clean this up. We have 4.5 equals 1.5a. We know that cancels out. So a equals 3. Okay, so we come back up to our original equation up here, and we rewrite that. A, so 3 over 2x plus 1 minus 2 over x plus 1. And that's our answer. Okay, so once you practice it, it shouldn't be too difficult. It's some factoring, it's some basically cross multiplication. You should be able to get that. All right, the last one will be